We are discussing an exciting paradigm shift taking place in the tech landscape. Generative AI-motivated migration from classical databases like Oracle or MS SQL to Amazon Aurora. First off, why are companies making this move? When migrating to Amazon Aurora from traditional databases, a whopping 90% of businesses have found they can successfully implement AI and machine learning use cases. But we won't sugarcoat it. There are risks associated with migration projects. Data loss, downtime, performance problems, data breaches, and business disruption can all pose significant challenges. That's where Mactores comes in. We specialize in using automation to mitigate these risks through our comprehensive database migration programs. Attend our workshop to learn more about how Mactores can guide you on your database migration journey. Thank you for your time.
My name is Dan, and I am your host today. I'm also represent Mactores. I run the business for Mactores, including our long-standing successful relationship with AWS. And I'm joined today by Ed White, who is their enterprise sales specialist for database, along with Shrikar Reddy, who is the database specialist solution architect for AWS. Also have my colleague Nandan Umarji, who's the sales principal and will be playing an active role today in demoing a number of automations. And my colleague Bal Harar from Mactores, who is also senior principal, heading our analytics and data sciences teams here at Mactores. So with that said, we're glad you're all here. We have a number of different things on the agenda today. But for that, there are a couple of things I want to call out on the agenda. First, we're going to address GenAI and why it's imperative, and provide a demo insights into the inner workings of that and how the database makes such an important piece. In addition, we'll spend some focus on the actual migration process itself, right? Showing how to mitigate the risks and how leveraging your database migration automations can save you tremendous amount of time and money, and again, applies to mitigating those risks. Yes, we are an advanced tier partner, longtime partner since 2008. We are highly squarely focused and specialized in database and data analytics and machine learning. And that's what we bring to the table today, and are excited to share our insights and our automations and our success stories to help understand how your journey can emulate such. Now, Mactores has approaches our business with our customers because we want to help them solve the three critical pieces. Typically, it's driving competitive advantages. It's also saving costs. And oftentimes it's operational, solving for operational inefficiencies. It's usually one of those three drivers that we're helping customers solve around. But with that, when we deliver, we're delivering faster, right? We're delivering 70% faster, and we're reducing the overall cost by 60 to 80%. Now, how we do that is highly effective because it leverages our automations. So obviously, by working with solutions with AWS and open source technologies and such, we're able to design for your use cases. And then we have a very agile process that allows us to get you to where you need to go. But all of that is leveraging the automations that highly reduce the risks and delays that can happen oftentimes in these migrations. And we'll be sharing insights into all that as we go further. And before I hand it over, I do want to make this offer to everybody that we have a free migration assessment and report that we're happy to set up with you. Of course, that would be one-on-one. It would be to your use case. We would need to figure out the best approach and how you want to provide all that. So please reach out to me and through the chat here at Q&A. In addition, we also offer, as an advanced partner, access to funding to help, alleviate some of those costs from migration projects. So we can talk about those things as well. So with that, Ed, I'd like to bring you in and have you kick us off with introducing us to the imperativeness of GenAI.
All right, so everyone has heard about GenAI, and I've never seen anything in the industry as long as I've been working that's taken over. I mean, basically since March, and this will probably be a review for most of you. But the interesting thing about GenAI is it can actually generate new content and for real world tasks. And so we're seeing a number of use cases it's powered by foundation models underneath. These are powerful models. The tasks that can be customized, quite amazing. Some of the work that we're seeing that can be automated. Use cases like text summarization, question answering. I mean, everybody's probably tried ChatGPT or Claude. The digital art creation, code generation, document preparation. I mean, the efficiencies, even we'll talk about Code Whisperer, where it can actually generate code for programmers. I mean, so it's really taken the industry by storm. When we talk about generative AI on AWS, we look at it across the broad spectrum. First, AI applications, that's where it really comes to life with things like Code Whisperer that can, a coding companion. We do QuickSight Generative BI. We have a new application for healthcare. Model building and deployment, we have Bedrock and Amazon Sagemaker. And we're unique on the model side because of the foundation models. We have our own Titan model, but we also work with the leading providers of other models so we can have that democratization, if you will, of the models across all the different startups that are coming out with these models. And then as Ball's going to talk about, vector database is extremely important as an enabler for GenAI. We'll talk about what we can do with Postgres today. And then the performant infrastructure, we're actually developing our own silicon with Trainium and an Inferentia EC2 instances. And we also, of course, partner with NVIDIA. At the end, it's still about the data. 72% of CIOs in a recent MIT technology study said their biggest challenge leading into 2025 with AI is the data. I mean, the AI is only going to be as good as the data underneath and the data platform that you can develop. And that's really a big focus of what we're going to talk about today. When people move to the cloud, they migrate. A lot of times they lift and shift, commercial databases, and, they get some benefits of cloud. But really what we want to talk about is how to modernize, how to move to cloud native databases. There's a lot of benefits from a TCO perspective, but it also now builds a scalable foundation to support your GenAI use cases. And this is one of the things I'm most excited about with our partnership with Mactores is how they automate a lot of the application code and the accelerators. And I, kind of championed this webinar because once I got to know them, I said, all our customers need to understand how fast and how easy in some cases they can modernize. A lot of times you just think it's too hard. So that's one of the big focuses today. When we talk about our relational database management service, is this in a self-managed environment, and all you guys know this, but there's so much that goes on behind the scenes under the covers, from failover, backup and recovery, isolation security is a big one, patching, how to scale up and scale down, advanced monitoring. I mean, I get tired just talking about this, imagining what you have to go through every day to self-manage these. And then there's also the value-added activities like schema design, query construction, and query optimization. What we do with relational database service, RDS, is behind the scenes, we take care of all of what we call the undifferentiated heavy lifting for you. So then you can focus on what we think is the more value added, the schema design, working with business users on queries, finding new applications. So that's when we talk about RDS, that's what we mean is behind the scenes. We take care of all the undifferentiated heavy lifting. And then the vector databases, it's exciting. I mean, how they can embed all kinds of data and the types of questions and answers and how fast. I'm amazed how fast the answers come back. And we'll talk about something called RAG, Retrieval Augmented Generation. We do this through OpenSearch, through Kendra, and also through Postgres, which is what we're going to focus on today. And so with that said, I want to turn it over to Mactores and really give you a taste of what this is like with a use case that they're going to bring it to life with.
A few basic concepts to understand how Aurora supports GenAI's journey. So as we all know, generative AI is taking the industry by storm. And one of the most important aspects of any GenAI solution is use cases. So to showcase what all use cases are possible, today we are starting with, we have created a demo of a bookstore. So it's kind of a sample data which we have generated to help you understand what use cases can be possible for a bookstore company. So this is we call this Bob's Bookstore, and we'll quickly see what do they do. So it's a online book sales and it's a online e-commerce company. They have built their application in .NET and Microsoft SQL. One of their major challenge they were facing was to reduce the cost of licensing, as well as to enable their end users to interact with a bot to help them answer questions, discover new books, and also generate a lot of content. Now, how does Aurora help do that? Is by creating something called as vector embeddings. Just a brief 101, what is vector embeddings? So vector embeddings have become very popular these days because what it actually does, it converts a text into numerical numbers, and which quickly helps customers to translate the data in the database and allows the machine learning models to train. This helps you are actively updating databases to quickly generate a training data set for all the LLM models or machine learning models out there. And you really don't have to export data out of database and create files for your machine learning teams to start processing. They can directly query your database to start working on the data for training. So what we are looking here is how do embedding models get trained on a vector database, and when they are querying for a particular use case, they can quickly understand what is the relationship between the question asked and the output which needs to be generated from a real-time perspective. And you really don't have to keep on exporting data into multiple storages, so your machine learning team can go ahead and train them. What we are going to demo today is a very basic architecture here. We have taken a couple of book descriptions as PDF files, as well as we have all our books for Bob Bookstore in the Aurora DB. And then we are using Kendra OpenSearch to index them for search, as well as we have created vector embeddings inside Aurora, which you will see briefly how that has trained our models for various use cases for Amazon Lex, which is a bot, to communicate with the client. So with that, let me just switch my screens to help you understand what are the different use cases we are talking about, right? So we have use cases where customers want to generate product descriptions and understand how they can efficiently answer these questions using this bot. So I'm just going to use some of the prompts which I have already listed, which makes it easy. So this is a bot which has been trained on the bookstore database, and as soon as I provide an input saying that generated book description for a book called as Attack on Titan Volume 13, and we can see this particular book. I'm sorry. In the Bob Bookstore. So this is the actual website which is running, as you can see. And based on the data which we have already in the database, this particular GenAI bot is now generating data which will make which will bring a lot of ease for the content company, their marketing teams, as well as their product description teams to generate content to quickly update in their email campaigns, to update on the website. So this gives a very quick an easy way to generate content from your database, which is trained on your database. Let's take another look at, can we personalize this data targeting personas? So in this particular case, I am saying, let's generate a content for a millennial crowd for top 5 books available, which are similar to a antiques roadkill, trash and treasures book. So what it can do is it will actually go and understand what are the different books similar to this book, these 2 books, if these are the 2 books I like, and generate a content which will explain what are the top 5 books I should be reading, with a brief description, helping somebody to get context of what is that book about, and if that is something what I would like to read. So it's a great place to also recommend books to end users. So how it is doing all of this, we will briefly see what runs behind the scene. I have a couple of things open in my second screen. But before that, I would also want to cover one more use case before we jump there, is now your marketing teams, or most of the marketing teams, want to take data from your databases and quickly generate email campaigns and want to understand what can really get sold faster, which will improve your top line. So this is an example where we can actually ask the bot to generate email campaigns for a persona here, which is the millennial crowd, and pitching 5 books similar to these top 2 books, which we saw very interesting. And it will go out and generate a complete email, which can be descriptive, explaining what the style of these books are. So these 2 books are mystery, nostalgic, immersive storytelling, which will quickly align to the crowd who is already reading these books and will start pitching other books in your inventory. Now, in this example, we have books, but quite literally, it can be different products which your team might be trying to sell over email campaigns. And so there are the possibilities of generating content, including text and image, are immensely powerful when we deal with GenAI. Now, let's look what is actually happening behind the scene. What we really have is this particular database where we have all the books. So if I select from the books table, we have all the books here with all the details. And here itself, we are actually creating vector embeddings for those books. So when the bot is trying to find out similar books, when the bot is trying to generate content based on the description, the bot has all the required embeddings available in the database. So as soon as the inventory gets updated, these vector embeddings are updated, and your model has the latest information. This can work similar with reviews on the book. This can be really real-time updated with every new table which you are trying to build in the book. The other use case we have also done is we have taken actually the documents of this book and converted those documents, which are PDF files, into vector embeddings, which is now helping the bot to also understand what that book is, to create a very personalized message. So I will jump into the Sagemaker model, which looks like, I don't want to take a lot of time, but just to explain you briefly how easy it has become today to quickly build a model with the database and then search the relevant data. So here, in this particular example, I am literally connecting to the database, selecting the vector embeddings, and providing a result of what it would. So if I'm saying, suggest me some New York Times bestseller books from the database, I'm literally going and selecting the data from my database, providing those vectors to my model, and that model will start generating the content based on the current, the current new updated books which are updated in the database, and start responding to our question, end user's question, right? Pretty straightforward, completely fully managed model in Sagemaker running with your Postgres database. So this is what we see as a power of using GenAI with Postgres, and helping you quickly update your data with vector embeddings for your teams to quickly start answering. So this is the motivation behind why we are trying to help customers adopt Postgres Aurora?
So hurdles of app migration, and we are going to take this presentation through discussing about various challenges that a business faces when they try to migrate the databases. And then we will continue the same example of Bob Bookstore, which is like an application into .NET Core and Microsoft SQL, and how migration from that to Postgres will happen in time. So let's start with some industry facts. Like about 60% of database migration projects fail, and in theory, like 62% of them, they fail due to the application and database updates. 76% of them, they have complex integrations and app dependencies, and about 57% has lack of comprehensive documentation and version control. So if you look at it, like many companies have a complicated application and database scenarios, which essentially means that one application connects with multiple databases and multiple apps talk to a single database. Like for example, in case of like e-commerce, maybe there is a separate database for user profile, product inventory, order history. So all of these databases are used by a single e-commerce application. Then in the other situation, sometimes like multiple applications are connected to a single database. Like if product inventory is the database, then e-commerce application, supplier application, loyalty rewards application, different applications can stay connected to the single database. That becomes a problem. About 24% of the companies say that they have established application and database version control systems. Some companies have application version control systems, may not have database version control system, and vice versa. So biggest impediments to all the application and database migration project is undocumented applications. And most of the legacy databases that the legacy applications or databases that we had were built 15 years ago, like during probably in ASP.NET, Microsoft SQL, or Java, Spring, and Oracle, and so on and so forth. Which means that most of those databases were relational databases, though the use cases were different, but still that was the only database available at that point in time. That's why it was the case. Many companies also face a code migration challenge because like over the period of time, though those applications were built in those legacy systems, and companies decided to upgrade databases from like 2005 to 2008 to 2012 and so on. But still applications remained monolithic, and that became another problem as well. So in the further slides, we will talk about the details on each of the challenge in migration and potentially how that can be solved, and basically what kind of automation can be used to solve that quickly and essentially de-risk the approach of migration. And we will see some of the components working in action in the form of demo. So first and foremost, like the applications with like about 15 years of legacy. So what happens? Like these applications, they likely to go through version upgrades over the period of time, but they follow similar monolithic project structure over a, I would say, modular or flexible project structure. Most likely you will find that business logic is written in stored procedures. They have tremendous dependency on outdated elements such as like link queue or data source controls, or very old type of connecting applications with databases. And therefore, they will have compatibility with modern systems. Because modern databases or modern applications should be designed considering high availability, global distribution, and active disaster recovery scenarios, legacy databases may not support these type of additional features. And these things, they result into additional downtime with more support, and that incurs 40% more technical debt. Most of these databases are built using relational databases like SQL or Oracle. And these faces like number of challenges. Like one of the fundamental challenge in that is about the schema rigidity. Like in the relational databases, schemas have to be fixed. Schemas have to be fixed. They have so many constraints. And then due to that, if you want to scale such databases, they will run into scalability issues. And then the more constants, the more performance trade-off. And these databases do not provide like flexibility to work on a lot of NoSQL use cases. There are many challenges with that, can be discussed into greater details, but these are high-level challenges of using relational databases to every single use cases. One of the other most common challenge that we find is undocumented applications and databases. Like there is always a knowledge gap between what the architecture is, what kind of different data structures do we have in the application. Sometimes like there can be issues related to data integrity and business logic if these things are not known ahead of time. Most of the times, companies rely on like the key people who have been with the business for the longer period of time to help them navigate through the process. But the reality is that multiple engineers work on the application. There are third-party vendors, contractors, consultants. Everybody contributes into this application, and it becomes practically impossible for key people to know what's going on in the system, even if they are with the business for the longer period of time. And we try to solve some of these challenges by deploying automated discovery and assessment tools, which essentially make sure that the analysis of application and database migration is happening based on the actual data and not based on the hearsay. These days, like obviously a lot of tier 1 vendors like AWS, they have automated tools for database migration. Like you might have seen SCT or DMS, which actually helps you convert schema from like Microsoft to Postgres or Oracle to MySQL and so on and so forth. We need to also change applications to make sure that this happens. Like because different database systems have different variations of SQL syntax, functions, and features. The application code that contains SQL queries, probably stored procedures, and database interactions, they may need to be modified to align with the new syntax. There will be issues with the data type compatibility, and therefore there might be issues in printing those data types into applications. So all that needs to change. There are definitely different constraints and different kinds of key structure in based on different database to database. And these types, if not handled properly in the application code, can become problem. There can be third-party libraries and frameworks which can also integrate with applications. So all of these application codes need to be changed in order to make sure that the application and database are compatible after migration. Whilst SCT is a great tool to do the database migration, there's a requirement of automated tools to actually discover all of these changes to be made in the application and eventually make that change. So we have some of the tools which can help accelerate that effort and make sure that all these migrations are done in a risk-free scenario. Of course, there are downstream data pipeline compatibility issues as well. Like most of this transactional data databases are connected to data pipeline in one or the other way. Either it can be with modern data lake or lakehouse kind of pipeline, or it could be traditional ETL pipeline with the use of tools like Matillion or Informatica into data warehouses. Of course, when those data pipeline jobs have to be modified for their data format and compatibility, otherwise we will face a lot of data consistency and integrity issues. If these ETL jobs are not modified correctly, they can result into performance bottlenecks, and eventually all of those things have to be de-risked to make sure that the migration becomes successful. In order to do that, we try to distribute all of this into different stages. So during the assess stage, we do the application load analysis, application dependency analysis, schema conversion analysis, and data pipeline analysis, the ETL analysis. During the design stage, we have to define the DevOps architecture, which helps us understand which these applications connect to, this database connects to how many different applications, what kind of connectivity is required. Is it private, public connectivity or federated connectivity required to control the right access? Then what is the change management philosophy for app and database? If there are no change management tools for application or DB, we have to deploy the change management, design and deploy change management system as a part of that. And we have to also design the ETL migration architecture depending upon what the source ETL system is and if ETL systems have to be migrated. During the build stage, we convert schema, migrate data, migrate objects, migrate data pipelines. Obviously, it includes the migration of automated migration of application code, database schema and objects, integrations, data integrations and APIs, and eventually data migration, which is one-time snapshot and the change data capture. Once all of this happens, a lot of organizations need help with the right kind of testing for schema, for data accuracy, for code, for application integration, load testing, and most likely the unit and integration testing. If companies do not have automation built in, automation testing built into the application, then we build that automation testing system in the source application as well as destination application, so that like the business is assured that their source and destination works perfectly fine. And obviously there has to be a cutover plan and there has to be a rollback strategy to make sure that all of these things work as expected during the cutover stage. So let's look at the cutover strategy in some of the detail. So usually, like during the cutover, first step is that we do the final schema migration, then full load and change data capture. So the data is loaded into Postgres. Automation testing validates the system. Meanwhile, that happens, business runs as usual on the correct system. Then we do data validate. So when the app gets pointed to the new database, the data validation on future system happens. After that, new application and database is available. During that time, we use CDC to migrate data that was lost during this period of time. The data gets loaded into Postgres. Meanwhile, as the validation is in progress, we stop the current application. Then data validation happens for future system. Then we connect with all the third-party applications and data pipeline. Then the present application remains in the stop stage. The new application becomes in production and business validation continues on future system. And when this is done, the application goes live on the newer database. Now, considering here that we are migrating from Microsoft SQL to Postgres. So all of this process typically happens somewhere between 0 to 15 minutes in most of the cases, but in very complex application and integration scenarios, sometimes this process can take about 1 to 2 hours. And idea here is to make sure that before we go live with application and databases and data pipelines, all things are thoroughly tested automatically so that the migration can be concluded confidently and in a risk-free environment. So to show some of these components, I would like to take you through a demo for a Bob Bookstore application, which is an e-commerce application based on .NET and MS SQL Server. We show how we do automated application dependency analysis, schema and database object conversion, data migration, then data validation with using DMS and advanced tools. And we will also look through the database and application version control systems. So continuing the application that Bal presented. So it's quite a functional application wherein you can actually look at the use book, decide that you want to add the book into cart, then go to cart, eventually log in and then place your order, so on and so forth. Now, as I indicated as usual, any application. So I spoke about during the assess phase, the application discovery and load assessment. So we deploy our tools into your infrastructure, and it is actually able to analyze the different user journeys that this application takes. So this is basically the Bob Bookstore, and this has port 80, which is obviously the web server or application server, and this is connecting to the Bob Bookstore database. So in the complex scenario, you will find like if the database is connected with any data pipelines or any other framework, or if there are multiple application to database dependencies, they will be mapped all here so that there would not be sudden surprises during the course of migration that some factors were missed during consideration. So it will also trace out all of the API calls and everything to make sure that all the it will help us understand the application dependency, which means that from which part of the application to which part of the database, how accesses are done, so that helps us understand what type of code needs to be changed to make sure that the application is compatible with database. Now, once that happens, we go to AWS schema conversion tool. So here, what I've done is I've connected the Microsoft SQL server database. So this is the Bob use bookstore database. This has all these different tables, and I've just selected top 1,000 rows to give you a view on what it looks like. So when you go to schema conversion tool, it actually lays out all the tables, all the views, stored procedures, all the database objects, and then this actually helps convert a lot of these stored procedures from Microsoft SQL into PostgreSQL. Like if you have used this tool, you would realize that some of the cases, in some of the cases, it cannot migrate from like some of the procedures, it cannot migrate from like Microsoft SQL into Postgres. So there we use our tools to actually help customers do that exercise to migrate. Essentially, these are very automated tools, but I'm just representing them in a UI. So when this happens in an actual setup, we build all of these things into a pipeline so that when the SCT report is out, which tells you what kind of code was converted, what kind of code was not converted. For the code that was not converted, the pipeline will actually try and access each of these unconverted situations and convert them into Postgres compliant scenario. So like I explained in the previous scenario, in the application discovery, it tells you at what places the application code needs to be changed. And using certain command line tools, like we can actually convert like all the applications all the application changes that were required to be done from Microsoft SQL into Postgres. So obviously, once all that conversion happens, we have to do a check on the data migration. So this is the standard, like the AWS DMS database migration tool. As you can see here, like we have created different database migration tasks. These tasks are, we can create one task for each table or multiple tasks per table, depending upon the size of the data that we have. And the task can be of full load and ongoing changes, which essentially make sure that one-time migration and change data capture can happen. DMS comes with a default validation to compare the data between source and destination. And however, we use some of the additional tools for like a detailed validation, which actually includes essentially identifies like tables, how many rows the table has, how many are the matching rows, what are the different rows. Sometimes during data type conversion, sometimes it might happen that it might miss some of the records. So it will tell you about which are the what records are different, what records are missing, and so on and so forth. So this actually gives us understanding on the, I would say, the mistakes that the automated tool might have done. The idea is to correct those, configure certain parameters, run those tools again, and then make sure that all the application and database is migrated successfully. So when all of this application migration, database migration, data validation happens, it's important to make sure that we load test this in the right way, which means we try to simulate the production load into the application and database to make sure that this goes in the right direction. With this tool, like typically we can like load the database to total transactions per user, what should be the ramp up time and minutes of test duration, and so on. and we can configure it to run specific procedures, specific functions, so that it can make us confident about the performance of the application and database during the actual situation. So the idea is essentially the idea is to make sure that at each stage there should be usage of the right tools to make sure that the application, databases, and pipelines are migrated seamlessly, so that you as an organization can be confident about executing these migration projects successfully.
With Mactores, you don't just get a services partner. You gain a partner committed to ensuring your transition to an Amazon Aurora database enabled with GenAI is seamless and successful. So whether you're looking to enable GenAI, integrate AI or machine learning, or gain performance, remember, a migration journey with Mactores is a journey to success.